Don't block the path of inquiry. Don't lay down rules that make it impossible for people to ask important questions.
Welcome to the Thought Stretchers podcast, where we hope to stretch your thinking about important issues in education through rich inquiry. My name is Drew Perkins, and I'm your host for these heterodox conversations for complexity. As always, thanks for tuning in. I appreciate you listening, and of course, we always appreciate it if you will share our work, whether it's our podcast or our blog pieces or our professional development work with those who might be interested. Speaking of professional development, WeGrowTeachers.com is where you can find all of our work for professional development, project-based learning, differentiated instruction, inquiry, and a whole host of other services that can help you grow your students to be better prepared for the modern world. As I've mentioned in the past few weeks, we've also launched our Thought Stretchers education community, which can be found at thoughtstretchers.org. If you're tired of the toxic back and forth on social media places like Twitter, this is a good place for you to be. You can go to thoughtstretchers.org and sign up, and there you'll see a number of posts that you can reply to, you can add to, and our hope there is to foster conversations that are more complex and nuanced and will help you in your professional learning journey. We'll also be hosting events and book clubs and salon-style discussions as we go on. We do have some in the works that have yet to be announced, but one in particular is in March, and that is with author Ron Richhart. So we have a book club on his latest book and an upcoming podcast about that as well. So if you're interested in that conversation, we have registration available. Again, you'll have to go to thoughtstretchers.org and sign up, and there you'll be able to RSVP. As always, if you have any questions, please reach out to me at drew@thoughtstretchers.org.
Americans on opposite sides of the political spectrum don't just disagree on the issues. More and more, they can't stand one another. This partisan animosity is the crisis of our time and threatens our nation. Braver Angels is here to address this. Our mission is to bring Americans together to bridge the partisan divide and strengthen our democratic republic. But no single organization, no matter how successful, can be powerful enough all on its own to heal this divide. If our goal is really to strengthen our democratic republic, our only practical strategy is to ignite and shape a broader movement for civic renewal. That's why we started Braver Network. At Braver Network, you'll find organizations from all across the country and all across the political spectrum that even when they disagree on the issues, come together to spark this movement for civic renewal. In building this network, we commit to equal representation, not just between conservatives and liberals, independents and nonpartisan groups, but also between national and community-level organizations. At Braver Network, you'll find the whole gamut, from businesses and leadership organizations to educational and religious institutions, all committed to improving our politics and strengthening our nation. We're looking for leaders and members of all kinds of organizations who are ready to lead and take part in the movement. Joining is completely free, and the opportunities for collaboration are endless. Help turn the tides of toxic polarization. Check out braverangels.org to sign your organization up for Braver Network.
In this episode, I spoke with Jason McKenna, who is an author of a book called What STEM Can Do for Your Classroom, Improving Student Problem-Solving, Collaboration, and Engagement, Grades K through 6. One of the things we started talking about was project-based learning and his definition of project-based learning, which certainly isn't terribly dissimilar from how we think about it, but probably some differences that are worth noting. One of the concepts that he advocates for is called guided discovery learning, so we explored that, which is certainly interesting in the realm of direct and explicit instruction versus inquiry, because as you'll hear me talk about discovery learning, is one thing that those more traditional education advocates often use. They talk about discovery learning and conflate it with inquiry, and that's a source of frustration for me, as you'll hear. I asked him about his planning process, the idea of foregrounding, and how that fits with front-loading. He also talked about the importance of creating, and that resonates with our work as well. And one of the things that he talked about was the creation of a product, and I asked him to kind of dive in and compare that to academic settings. We ended the conversation talking about the importance of trust and creating an environment where it's safe to fail and learn from that failure. And then I asked him to sort of unpack and give an elevator pitch of his book. STEM is obviously a popular topic in the education realm, and project-based learning is closely related. So hopefully this conversation is helpful. And without further ado, here is that conversation with Jason. I am here with Jason McKenna, and Jason and I are going to talk about some things with regards to project-based learning and STEM, and I think guided discovery learning. I have some questions about that, and all things sort of related, I guess, to those kinds of topics. But as I usually like to do, I want to give Jason an opportunity to say hello and to introduce himself, give our listeners a little bit of background on who you are.
Appreciate that, Drew. Appreciate you having me on the podcast. I'm a fan. It's really an honor to be here, especially considering some of the other guests that you've had on your podcast, some of the other authors. So it's really a pleasure for me to be here. I'm a former teacher. I still consider myself to be a teacher, even though that's not my job title now. But I taught for 20 years at a small school right outside of Pittsburgh, Pennsylvania, about a half hour north of where I'm talking to you from here today. I'm in downtown Pittsburgh today. So I got hired to teach in 1997. I taught fifth grade my first year, and then the subsequent 14 years, I taught sixth grade. And about that time, about year 15 into my teaching journey, I was pretty burned out. I was tired of teaching diagramming sentences, and I was tired of teaching the same math lessons over and over again. And I was looking for something new, looking for something different. And the gifted position at my school came open. So my school used to have a K-6 gifted position, and they also had a part-time high school 7-12 gifted position. They decided for different reasons to combine and make it K-12. And I'm dual certified. So I have an elementary certification, also a secondary history certification. So I got the job. I became the K-12 gifted coordinator at my school, and I was all kind of excited. I couldn't wait to get started. I thought this was going to reinvigorate everything. And at my school, gifted fell under the purview of special education. So I went and I met with my director of special education. I was like, I can't wait to get started, blah, blah, blah. And I got cut off halfway through, and they were like, listen, I don't care what you do, just don't get us sued. And I said, oh, okay. So I did that for a month. I didn't get us sued for a month. But the burnout didn't get fixed because nobody was shut off from my classes, this, that, and the other thing. So I went back to my director of special. I said, listen, you got to help me out here. I got into this whole thing because, I was not happy, and I'm looking for something new here, and nothing is happening. And so she goes, all right, I'll tell you what. Give all the students a survey, have them fill it out, and I'll pay for a sub to come in so you can rewrite their GIEPs, their gifted individualized education plans, see what they want to do and go from there. And I'm like, fantastic, this is awesome. So as I mentioned, I have a secondary history certification. I'm a history buff. So I'm thinking these kids are going to want to learn about World War II. We're going to talk about all this other cool stuff. Well, they come back, I get the surveys back, and they all want to learn robotics and computer science. And I'm just like, oh, man, I don't know anything about robotics and computer science. And that's what basically started the journey to where I am now. The reason why that was is because Carnegie Mellon University used to run a summer camp called C-Mites. And at that summer camp, these kids all got a chance to build and code and play with robots. And that's what they wanted to do. They wanted to come back and do that in school. But as I mentioned to you, I was scared out of my mind because I couldn't build or code a robot, even what a robot looked like. I'm not thinking robots, I'm thinking R2D2, basically to save my life. So I went to Carnegie Mellon's Robotics Academy to basically get some professional development and figure out and wrap my head around all of this. That led to me working part-time for them during the summers, helping to write curriculum, helping to do teacher PDs, essentially helping teachers that were in the same position that I was, where they were scared to death to do this. That then eventually led to me working for a small Carnegie Mellon spin-out called RoboMatter, which was then purchased by Vex Robotics, which is the company that I work for right now. And that is what eventually led to me writing my book about STEM education, as you mentioned, about project-based learning.
Okay, so you have switched teams from the social studies realm, which is my background, and jumped into robotics and STEM. So I share a little bit of common ground with you. I got into 15 years of teaching myself, secondary social studies, some special education, although on the other end, not gifted, but emotional behavior disorder. And at the tail end of that 15 years, I was really, really burned out. And I remember when I left the classroom, my wife at the time asked me if I was happy to be out of the classroom. I said, no, I'm happy to be out of that classroom. And it wasn't really necessarily the kids so much as almost more the adults and what didn't feel like, I felt like I was a fish swimming upstream. One of the things I was trying to do was more project-based learning, and that kind of was contrary to the other, the directives and initiatives that we were doing at that time, although ironically, several years later, there was an initiative to do project-based learning. And of course, my former colleagues are like, wait, this sounds familiar. Somebody else was trying to do this. Wow. So that was part of it. There was also some other factors that I felt led to my burnout. I'm curious, other than the fact of, diagramming sentences, which I certainly can understand would lead to some burnout, at least from me, what were the things that kind of got you to that place of burnout?
Honestly, a lot of the same things that you mentioned. I've told this story a few times. When I first started teaching, I was teaching language arts in my fifth grade classroom. And, I like to say there's nothing worse than teaching a group of bored students, apathetic students. The students are bored, you're bored, everybody's miserable, right? And I was trying to teach language arts and it was not going well. The students were bored, I was bored, and these stories that I was teaching from were terrible. They were just horrific. And I'm like, why am I doing this? Like, these stories are terrible. So what am I trying to teach? I'm trying to teach context clues. I'm trying to teach, find the main idea. I'm trying to teach vocabulary. Well, what if I did that through a different means? So I have these stories. These stories are terrible. What if I found more interesting stories and I went and I taught the same things? Now, to you, Drew, that might not seem that controversial, but let me tell you, in 1997, that was very controversial at my school. Like, you would have thought I was doing something completely and totally out of the realm of normal and damaging these students. And I started to teach language arts outside of what was in the prescribed textbook. I started to read I'm a humanities guy at heart, so I started to do some Shakespeare. We read some sonnets. We eventually got to the point where we were doing Hamlet in sixth grade, and wildly controversial at the time. And I kept on having to answer the question when they would come to me and they would say, whether it was my principal, I had to have this conversation with my superintendent where it was like, Jason, are you following the curriculum? I would say, well, how are we defining the curriculum? Are we defining the curriculum as the tools that we are using to teach the students, or are we defining the curriculum as the ends that we want to actually be able to achieve with these students? And I had that conversation, and having to have that conversation over and over again was very frustrating for me. Parents loved it. Kids were now energized. The kids were enthusiastic, but having to deal with, lack of a better term, the bureaucracy of that was very frustrating for me. And kind of like what you had mentioned, around project-based learning, I wanted to explore different ways of teaching. I always felt that I was trying to find a way to teach that best fit my classroom that particular year, or best fit the individual needs of that student. So I would try different things. If it worked, great. If it didn't work, well, let me learn from that and try something else. But that process of iteration, kind of applying it to my teaching methodology, was also something that was oftentimes frowned upon in my particular educational setting. And again, I found that to be very frustrating.
Yeah, well, one of the things that I was also frustrated about was what felt like a lack of intellectual nourishment and collegiality, and having those discussions with colleagues in a sense of sort of professional learning and ongoing professional learning. So I'm curious, with your pre-service and I guess however your certification path was, what was that? What was that like? And what were some of the things that you learned or maybe didn't learn in your pre-service?
So one of the biggest lessons I learned once I left the classroom and came into the quote unquote boardroom, so to speak, was the importance of stakeholder management. So if I had to go back and do it all over again, if I could go back in a time machine in 1997, it's a little bit arrogant for me to sit here and say that, well, I was doing all these great things and nobody could just understand what those things are. And if everyone just would have listened to me, everything would have been fantastic. But instead, what I now realize and what I did not learn, to your question, what I did not learn when I was in pre-service education or when I was in college was the importance of engaging folks and engaging people and talking to them and engaging different stakeholders so that I could go into teaching language arts with a different textbook, where I could go into a new teaching methodology and try those things out, and essentially having everyone on the same page with me. Does not mean everybody necessarily has to agree with me, but what I do need to do and what I should do is go and have a conversation with people to give them an idea of what it is that I'm trying to do, get them to understand the why behind what I'm trying to do. And again, try to get everyone on the same page. And maybe through that conversation that I have with those people that I learned something, hopefully they learn something also, and that can all go towards the betterment of our students. But I didn't do that. I thought I was, and I think this happens a lot. I see this a lot, that, teachers think that they're on an island. I shut the door in my classroom and that's it. It's just me. And it is just you in that particular sense. But if we could think about all of us, together and thinking about how we're trying to achieve these goals and these means with our students together, I think that's a much better way to go about it. And I learned that, unfortunately, when I came into business as opposed to when I was going into education.
So where was your teacher? What was your path to certification?
When I went to college, I went to Geneva College. Again, right here in Western Pennsylvania, and that's where I got my elementary teaching certificate. Then when I got my master's degree, I was, at the time it was called Clary, now it's called Penn West. I got my master's degree in instruction there, administration instruction there.
Okay.
So it's the normal routes,
right.
I guess, quote unquote, to teacher certification. Yeah.
And did you feel like that prepared you well? I mean, you certainly noted some things that you wish you would have done differently, but I think a common theme and criticism, complaint of teacher pre-service and, professional development in, on the job is that it's generally lacking. I'm curious, how you've experienced that and what your reflections are on that when you were in pre-service and then as a teacher.
So my professional development when I was a teacher, I would categorize probably 95% of it as being poor. Yes. My pre-service teacher, I had some good professors in my pre-service education, but in terms of the actual understanding of how you teach and understanding of what is it you go through when you teach, most of that I found out through my self-education, when I started teaching. I've learned a lot. One of your previous podcast guests, Daniel Willingham, I probably learned more from his books about the science of learning than I did, in my pre-service education or in any professional development that I did during the course of my career. So I would share a lot of the same criticisms around professional development, not being really impactful or helpful for teachers. I would take probably a different approach to it, though, than what I've heard a lot of people take to it. When I hear a lot of people criticize either pre-service teaching or current teacher professional development, it's around practicality. I want some things that I can take back to my classroom and I can apply to my classroom. And I think oftentimes that's needed. I think it's necessary, but it's insufficient. I think instead, what we have to actually do is we have to challenge ourselves to think very deeply about what it is that we are doing in our classroom. And there's not a prescribed answer for that. When I went through the process of writing my book, the editors that were my book with were fantastic, but they kept, preaching to me, we have to give teachers practical takeaways. We have to give teachers practical things they can apply in the classroom.
Yeah.
And that just screams to me, you're watching a movie, then at the end of the movie, like a title card comes up and it's like, this is what you should take away from this movie. And if we were ever watching a movie and that came up, we would probably be insulted as an audience, right? Because you take away what you take away from that movie. You combine what you saw with your own personal experiences, your own personal judgments, and the combination of all those things are the conclusions that you take away from that movie, which is why, you could watch a movie, Drew, and I can watch a movie. We get entirely different things out of that. So I think that process is very important for teachers because all of our students are different. All of our classroom environments are different. All of our schools are different. We're all dealing with different things. So to prescribe one thing to be able to attach to all of that, I think, is the wrong way to go about it.
Yeah, in our professional development work, we definitely try to, and sometimes, and usually do, ask right as we're getting started, like, what would be an outcome that would make this time investment worth it to you? And oftentimes the teachers in the room will say something like, something that I can use tomorrow and the next day, that kind of something practical, right? And I totally get that, and we actually certainly do that. Like, we ask them to engage in things and say, okay, you can use this tomorrow, and it's in service of a bigger picture. But there is, I think, to your point, sort of a larger process of really ironically, or I don't know cynically or something, says, stretching the thoughts, right? Thought stretching, right? Like, how do you think differently about this, and then ask some questions and be a little bit evaluative about that process. So it is difficult, and as you're well aware, my guess is, and certainly every teacher is well aware, that the process of professional development and how that is applied to teachers, not with teachers, is often a little frustrating to maybe understate it. But well, let's talk about your work, and project-based learning is I guess one of the ways in which you describe your work. Guided discovery learning, of which I'm curious to hear more about that. Obviously STEM, and the book that you have is What STEM Can Do for Your Class. It's from Solution Tree, and we'll make sure to talk about it at the end for sure, and link to it. I guess maybe a good starting point is how I'd like to learn more about how you define project-based learning, because it's not necessarily universal in everybody's sort of operationalization of it.
So I describe, I think, as you mentioned, the opera how it operates, how it's actually manifested in the classroom. I think that's an important thing to think about, project-based learning. And as you mentioned, I talk about my book, guided discovery learning. So I'm gonna zoom out for a second, and then we can zoom in to make sure I specifically answer your question. So I struggled mightily when I was teaching the classroom. I felt like I was being pulled between these different camps when it came to do project-based learning. So to do more open-ended inquiry, to have the students try to solve a project that was open-ended, try to choose their own path as they were going through and doing that. That was something that I thought was very appealing. But then it was like, okay, do they have the necessary and the basic knowledge and skills, for lack of a better term, to be able to actually go through and do that, right? As I mentioned to you, as I kind of went through my own self-teaching to try to figure that out in the classroom, what I quickly found out was, that there's these two different camps, and the camps are called different names a lot of the times. But in my book, I refer to them as the knowledge camp versus the skills camp, right? Mm-hmm. So you have the knowledge camp, which is and I know these terms are all fraught with different meanings and whatnot, but I'll just call it like lecture based, where it's like you do direct instruction with the students. Mm-hmm. You go through, you teach them these particular items. You quiz or test the students on those items, and you basically repeat that. And then you have the skills concept of it, which is, we have to teach these students generalizable thinking skills, because that's what the world needs right now. So the World Economic Forum comes out with, these are the top 10 skills that are, that people need in the workplace today. And it's like solving unstructured problems, it's being able to work collaboratively, it's being able to problem find and critical thinking, all those different types of things. And that's normally what we would put under, what a lot of people put under the heading of again, project-based learning. But which one do I do, and when, and how do I apply those things, and which of these two camps, is the right camp to be able to do that? And when I was teaching, I often thought I was ping-ponging back and forth between those two different things, where it was like, okay, I need to really focus on the fundamentals here, or I really need to focus on teaching my students, quote unquote, critical thinking, in a project-based learning format. So where I came across when I started working at CMU, and where I came across what I describe in my book as guide discovery learning, is really that we don't have to choose between those two things. It's kind of a false dichotomy, right? Whereas we can do direct instruction, for example, and then we can also do open-ended inquiry and do those types of things together, in a project that we're actually having the student do. So what I describe as guided discovery learning, in my book is, first of all, you have to make sure, number one, kind of the first step in that is that you have a clear goal. So you have to make sure that the teacher and the students both understand what success looks like. So we both feel like we're working together to achieve this thing. We both understand what this thing is. So we both understand what success looks like with this particular project. After we do that, then step two is, do we understand and do we have the skills foregrounded for us so that we understand, we can then actually work on that thing effectively. So when I was still part-time, actually, I was still teaching, one of the projects that I was working on was called the Robot Algebra Project. And this was a project at the University of Pittsburgh and Carnegie Mellon Robotics Academy. This was a joint project that they were working on, and it was all about using robots to teach proportional reasoning. So can I use robots? So proportional reasoning kind of undergirds all of secondary math. It's kind of the capstone of elementary math, right? So it's a really important skill. Can we use robotics as a hands-on way? Can we use STEM as a hands-on way to really teach proportional reasoning effectively? And we did that project for about a year, and it failed miserably. So the kids didn't learn anything, right? And so why? We thought this was a great idea. We thought this was a good application. And when we kind of found the root cause, it was because what we were having the students do was, the wheels on the robots were a certain size, and then we would use wheel turns to see how far the robot went. If we changed the wheels out on the robot, then can we predict, or could we mathematically conclude how far the robot would move? That's how we were trying to gauge proportional reasoning. One of the things that undergirded that process is the students had to they had to measure how far the robot was moving. They had to measure the diameter of the wheel to find the circumference, and they couldn't measure. So these were seventh grade students that did not know how to measure. As a result of that problem, they could not then do the proportional reasoning because they were kind of fraught from the start because they didn't know how to measure. So we went back, we changed the lessons, we changed the activities so that we made sure that we foregrounded that in the activities, the students knew how to measure. And then after we did that, then they went through the process I described a moment ago to learn proportional reasoning. And then in the second year of the study, it was massively successful, right? So foregrounding the essential skills that the students need, that's step two. And then step three is doing the formative assessment to make sure that they actually have mastered those skills. So don't just guess at it, actually get some evidence from the kids to ensure that those skills are foregrounded. Now, after we've done that, we've created a clear goal. We're both on the same page of what success looks like. We have foregrounded all the necessary skills. We have gotten some evidence to ensure that those skills have been done. Now in step four, now we take the scaffolding away. Now they can go and they can unleash, for lack of a better term, of what they've just learned in a different context. We take the scaffolding away, as I just mentioned, to them, and we have them apply it. And that's hopefully where the transfer that we're all trying to get actually occurs, and that's where it happens. So to zoom back in and to answer your question, that's how I would define project-based learning, kind of within that construct that I just mentioned to you right there. That's how I would define it. I know there's a bunch of different definitions out there, but that's how I would define it. I would define it through its application as I just described to you.
Well, interesting, I think, is the term that you're using, or I guess phrase, or whatever that might be, guided discovery learning, because as my guess is, you're well aware that the folks, and this is a frustration that I talk about ad nauseum, so folks are probably like, oh, here he goes again, but the direct and explicit instruction advocates and evangelists really, I think, use the term, and they certainly have written about it, as discovery learning, and conflating that with anything basically inquiry. And one of the things that I really try to push back on is, as you mentioned, it's not a binary, and effective inquiry instruction, project-based learning being one of those ways to access that kind of approach, should and does include direct and explicit instruction. And it's pretty clear from the evidence that discovery learning, which I would characterize, and sometimes I joke about, as free-range chicken, kids just sort of wandering about without any real academic guidance and leadership, that there are some settings where that does work, but it's not particularly effective in most academic settings, because there are certain things you want them to learn about. There's a cognitive path you want them to travel. And so what frustrates me in that sort of debate, for lack of a better term, is that they conflate it and use that as a straw man. And so the idea of calling it guided discovery learning, it's interesting, and I'm just sort of giggling at the thought that they might, at their reaction, those folks who are, I would say, sort of evangelists, right? They say, just be triggered by the word discovery, and probably would say, it makes some sense to say guided and discovery don't go together, because essentially discovery is without guidance. And so that it is an interesting term. I'd be curious to get some reactions from folks that, again, are sort of in that evangelistic, direct and explicit instruction camp. So when you think about project-based learning, is there a structure? And I mean, you outlined sort of 4 steps. Is that the sort of format that you lean into? Are there planning documents that you tend to use? PBL Works certainly has theirs. We have ours. There are definitely some others out there. I'm curious if you have or recommend a set of planning documents or steps that are sort of accompanying these 4 steps that you mentioned in your guided discovery learning process.
Yeah. So what I talk about in the book is, I think that process that I just described for you, kind of like that 4-step process, kind of subsumed under the entire engineering design process. That makes a lot of sense to me, because I think those things mesh together very, very well. I didn't learn. I mean, it's in the next generation science standards, like it's mentioned to it, but I didn't really understand the engineering design process until I actually started working with engineers, both software engineers and mechanical engineers, electrical engineers. So, you were talking about, you were social studies teachers. I laugh all the time about it. Like I consider myself to be more of a humanities person, and I work with engineers literally all day. But they're great, and the thing about it is really trying to understand at its core, the engineering design process and what it entails. If you think about the difference between like an engineer and a scientist, for example, is a scientist investigates where an engineer is always looking to create, right? And I think that's why it fits in so well with project-based learning, because at the end of project-based learning, oftentimes, as I've seen it applied, is you're trying to create a product. So you're trying to create something, right? So as you're trying to, so that's why it fits in so well with the engineering design process. Now, to your point that you mentioned earlier about some in the direct instruction camp thinking that guided discovery is oxymoronic, I think they would spend it would do them a lot of good to spend some time with engineers, right? To spend some time with actual engineers and to see in the quote unquote real world how engineers actually create a product. Now, one of the benefits of my job that I have right now is I've been able to be a part of, I think at this point, think about 8 different product launches. So from initial idea to get into the hands of customers, I've done that around 8 different times with 8 different products, right? One that is particular to the conversation that we're having right now is when we were in the very beginning of the pandemic. So Vex Robotics is the company, that I'm the VP of global educational strategy for Vex Robotics. So we create, STEM education products for students from 4 years old all the way up through college. So everything we do is very collaborative and hands-on. So schools are shutting down. Teachers are going from classroom to teaching from their living rooms via Zoom, right? Well, there's no collaborative and hands-on, obviously. So it's in April, I think it was 2020 is when the world started to shut down, and I'm walking my dog, and Bob Mimblich, who's the co-founder of Vex Robotics, calls me and Tim Freeze, who's our VP of Educational Technology, and he's basically like, what are we going to do? We have teachers, we have Vex teachers out there, STEM teachers out there that can no longer teach because there's no more hands-on, there's no more collaboration. Everyone's going to be teaching via Zoom. What are we going to do? So we start talking about, as I'm out walking my dog Anka, we're talking about this, and we're like, well, what if we create a virtual robot? And they can learn how to code the virtual robot, and we can do some things to help make it collaborative, do this other kind of stuff. So we have this conversation, and 3 weeks later, I'm doing a podcast from my basement launching VexCode VR. So that product now is being used by over 7 million students. And I think it's, the last I checked, is 210 countries, and over 7 million hours of code have been done with VexCode VR, right? So by just about any metric, you could say it's been a tremendous success. But to your question, to your point, what is the product? What is the product? Is the product the if you go to vr.vex.com and play it, is that the product? And I would say no, that is not the product. I'm going to be at FETC at the end of January. I will bet you a cup of coffee, Drew. At FETC, I will have a teacher come up to me and say, Jason, thank you so much for releasing VR during the pandemic. That saved my teaching career because I didn't know what I was going to do. I was scared out of my mind. I am a STEM teacher. I didn't know how long this pandemic was going to last. I didn't know what was going to happen with it. And I saw a way that I could keep teaching Vex and I could keep teaching STEM through VexCode VR. I can't tell you how much I need to thank you for that. That's the product. That's the thing that we were trying to create. That's happened at every conference I've been to since the world reopened back up over the pandemic. Now, how do we all get on the same page about that? Because if you think, Drew, the product is a virtual robot, or the fact that I can code it in blocks, or the fact that I can code it in Python or the playground, and I think the product is what I just described to you, if we don't do that first step, we don't define success together, then we're never going to make the product successfully. And I've seen that happen. I've seen unsuccessful products be made because all the stakeholders are not on the same page. That's the guided part. And now, as we do that, we're going to discover the product together because we might think it's going to be this one thing, but it might not end up being that, right? So I'm assuming you're about the same age that I am. So you probably grew up like I did, right? You were told never get in a car with a stranger. I remember going when I was in 5th grade, that the police would come in, they, stranger danger, never get in a car with a stranger, right? That's Uber's entire business model. So if Uber went and talked to a bunch of people and they were trying to create a quote unquote product that we knew ahead of time, that didn't exist. No one wanted the iPhone before it existed. So if you're Steve Jobs or if you're Uber, we all get together and we think together that we're going to have an idea of what it is that we want to create. We all get on the same page. That's the guided part. But as we go on this journey, we're going to discover potentially something else because sometimes the public doesn't know what they actually want. That's the guided discovery part. And that's what great companies, innovative companies, disruptive tech companies, that's what they're doing every single day. So again, to your earlier point about some people in a direct instruction camp thinking that guided discovery is actually oxymoronic, I would argue back to them that you've never actually created a product before. You've never actually done project-based learning. We've had to create a product, because sometimes when you create a product, it's not what you originally intended. But at the very beginning, you have to be on the same page about it.
Yeah, well, so lots of that resonates with me, and we think about project-based learning from our perspective, and one of the things you mentioned is like creating something, right? So we always want to have some verb in our driving question. I'm curious if you use driving questions, because sometimes people in the STEM, it's sort of like an implied, like you're trying to build this robot to do this or that kind of thing, and we really want to do that intentionally and have that verb that's if it's not created, some synonym of that. Mm-hmm. And we talk about Bloom's taxonomy being a good framework to sort of simply discuss that, and thinking about, all right, we want the students to start at the top of Bloom's taxonomy if we're using the traditional hierarchy and pyramid, create being at the top, and then look at the knowledge and understanding pieces that are at the bottom of that pyramid, and the need to know list of identifying what it is we need to know and understand, the questions we need to ask and answer in order to do that. And then, of course, through the project, we're doing the middle pieces of that pyramid. One thing that I can imagine as a pushback to what you just said, from especially direct and explicit instruction advocates, is that, well, that all of that may be true, creating a product and launching a product and that kind of thing, but what we're really talking about here in most cases is an academic setting, right? That we're not launching a product, we're trying to get kids to learn about something, and so that's a little bit different, and some might say very, very different, right? And so, is there, in your sense, a real clarity in, I guess, how, like we think about an academic setting that we have these 5 or 7 or whatever standards and things we want them to think about and learn about. And from our perspective in the planning process, that's where teachers start. And those are the knowledge and understanding pieces, and those are the things we want to come out in the need to know and learn list. But sometimes in robotics or STEM or in pure discovery learning, there isn't that, right? Or genius hour, right? That people will call that project-based learning, and it can be some version of that, but that there's not a necessary and desired educational outcome that we're after, that we have to scaffold and plan and design and then implement those projects or whatever instruction we're doing. So I'm curious your reaction to that.
So I think when you're mentioning that, what initially comes to my mind is like the assessment component of this, right? So what are those few things you mentioned? Standards a moment ago. You mentioned I can't remember the know and learn sheet. I think you mentioned that.
Need to know and learn list.
Need to know and learn. Thank you. Those types of things. So I think I'm glad you mentioned that. So that's where my mind went. So with that, I think one of the things that you have to do, and you mentioned this in the context of professional development, which I agree with. I also take it to students as this idea of making students actually part of the assessment process. So assessment is not something that you do to students, but instead something that you do with students. So we want our robot to be able to grab an object and place it over here. So our robot is, they oftentimes in hospitals now, they use robots to deliver medicines to different people in the hospital rooms. It's a faster, more efficient way to be able to do that. They always deliver the correct medicine, things of that nature. So now we're going to replicate that in our classrooms. So we're going to create a med bot, and this medical robot is going to deliver a package, which we're going to say is medicine, to this particular spot. So Drew, you and I are not going to sit down, and we're going to identify what is it that we need to know in order to be able to have that happen. What is it that we have to identify to do that? And then at that point, the student can say, well, I'm going to have to be able to code the robot to drive forward, to turn, to do all these different things. Okay, so let's talk about that. So let's talk about those particular things. What else do we have to be able to do? Well, I'm going to have to be able to actually, build an arm and a claw so I can grab those things, right? So I'm going to have to open, and I'm going to have to build a manipulator in order to be able to do that. Okay, let's go through and let's identify those things. And then as you go through that, then you can get it more into quote unquote the soft skills. Well, I'm going to be in a group of 3 or 4 other students, so we're going to have to identify together, or we're going to have to work together in order to be able to accomplish this. So once one person is going to have to be in charge of potentially building the chassis of the robot, another person is going to have to be in charge of building the arm and the claw. Maybe the third person, maybe they're doing more of the coding. Maybe the fourth person is identifying the path the robot has to take in order to be able to deliver the medicine in a timely fashion in the little field that we have here in our classroom. And we're all going to have to work together to be able to do that. So how do we do collaborative decision making in order to make that happen? And then how do we document those things? And those are all things that we can identify as being learning outcomes that we want to achieve as we go through this process. I think then the art of the teaching aspect of this here goes back to whatever it is I'm trying to teach, whatever those standards are, right? If it's a 6th grade standard or 5th grade or middle school, high school, whatever, can I find an activity, or can I find an organizer that's really then going to bring those things out? So if I'm teaching, if my emphasis is computer science, for example, and I want my students, one of the big standards I want to be able to teach is my students are able to understand and apply sequence, selection, and iteration so they can develop an algorithm. Does this project that I've created from a teaching perspective, is that going to then authentically ask the students to create an algorithm or be able to solve this problem, right? And then, oh, by the way, in the course of doing that, are they also going to do those collaboration skills that I have a standard that I want them to be able to achieve also? So I think the real kind of magic, or the art, as I like to say, is choosing those projects that are able to authentically derive those outcomes that you want to actually be able to achieve with your students. But then I think the important part then is instead of beginning that whole thing by listing them on the board and say, like I used to do when I taught, and say, okay, kids, here's all the stuff that we're going to learn over the course of the next week or two as we engage with this project. Instead, it's having that conversation with the students and then bringing those things out together and then monitoring, as I mentioned with the guide discovery learning process, monitoring it as it's applied throughout the course of that project.
So is that what you described there, just in those last few sentences, is that what you're meaning by the foregrounding of essential knowledge? Because when I see the word foregrounding, I get a little suspicious insofar as when we do work with project-based learning, sometimes we'll hear about this idea of front-loading. And maybe it's just the word, the letter F that's catching my eye, right? The sort of front loading of the knowledge, and people even who are sort of more in the traditional camp will say, oh yeah, we can do a project after they learn all the stuff. So the front loaded, they'll teach it ahead of time, I guess, and then launch into a project, which we say, well, it's not necessarily the worst thing in the world, but it's a missed opportunity to help students and facilitate that process that we think is really, really important. And one of the reasons to do project-based learning is to say, let's identify and get good at, or at least get better at learning how to identify what we need to know, the questions we need to ask and answer in order to do something well. Because while lots of research says critical thinking skills and some of those processes that we're all after and businesses are after and industry and entrepreneurs and so on and so forth, lots of evidence says that those skills are tend to be domain specific and not particularly transferable. Although I would say that those are, sort of more general skills are things that are transferable, and so there's a distinction there. But anyways, I've thrown a lot at you. I'm curious about the sort of foregrounding essential knowledge piece, especially.
Yeah, and I think I really appreciate your podcast and your perspective on this, because I think you provide the necessary nuance needed on this, because, like you said, it's not binary. Let's just stick with that example that I said, that the students are going to have to be able to create an algorithm, for their MedBot to be successful, right? In terms of the foregrounding, like, they're going to have to know some basics of coding, right? They're going to have to understand, like, you can't come in as a complete and total novice who's never actually download and run a project on a robot before and expect to be successful at developing an algorithm. So through your teaching or through the experience of the students bring to your classroom, I interchange foregrounding or activating prior knowledge, either one of those two things there, right? Mm-hmm. They have to have some level of experience in order to be successful. And that's where the direct instruction part comes in. If they don't know that, then we need to supply that to them, right? Mm-hmm. Now, what I'm not going to do, and I think this is what you were getting at there, what I'm not going to do is I'm not going to say, here are the commands that you need, whether it's a loop, whether it's a basic drivetrain command, whether it's a conditional statement. Here are the commands that you need in order to be able to create the algorithm to get the robot to be able to do that. That's what I want the students to, quote unquote, discover on their own. That's what I want them to derive on their own, because one of the reasons I fell in love with this, with teaching STEM and teaching robotics, is, again, not because I spend my spare time coding. I do not. Not because I spend my spare time tinkering with robots. I do not. But, I struggled when I taught with having my students find different solutions to problems. That was one of the things that was being emphasized, when I was teaching, was, hey, have students investigate different ways to solve problems. And I had a very difficult way. I had a very difficult time teaching that when I was teaching. And then when I started teaching robotics, they did it. Now, that's not to say that robotics is the only way to do that. I'm sure, Drew, in your experience, you found many other mediums besides robotics be able to do that. And that's great. But that's when the light bulb went off for me. That's when I fell in love. I had a simple project. The very first project my kids did was make the robot drive in a square. And I had 4 different groups and I had 4 different answers. And I was like, oh my goodness. Now, I'd spent the previous week doing the basics I just talked about with you, where it was like, here's how you open a project. Here are the basic commands. Here's some information about the commands. Let's do our first project together. Let's run the robot. Congratulations, we all programmed a robot. Let's high five each other. This is great. Now, after we've covered those basics, okay, now here's the challenge. Okay, we're going to make our robot drive in a square. And I forget how I themed it. I did this other activity, which was kind of cool, which was greeting an alien, right? Which is like, what do we use robots for? Well, what do we use any type of machines for? Well, we often use robots for things that are dirty, dull, and dangerous. The 3Ds used to call them when I taught, right? So it's an application of dangerous. Let's say an alien shows up. Well, we don't know if the alien's friendly or not. So I don't want to go say hello to the alien and talk to it. Let's send a robot. Okay, so what do we have to do? Well, the robot has to drive to the alien, has to stop, has to make a noise, and then turn around and come back to us. If it comes back to us in one piece, we can assume that the alien is in good shape. If it does not come back to us, then we got problems, right? So that would be one of the first activities that they would, quote unquote, apply what they've learned in a discovery fashion, a project-based learning fashion, to show me what it is that they learned. And I would have many different ways that the students would code their robot to be able to, sometimes they would use a sensor, sometimes they use basic drivetrain commands. But I think that gets to what you were talking about there, of the balance between the two. Yeah,
in some ways, I often articulate it as a sort of our order of operations issue. And so far as in a project-based learning setting, as we think about it, is, again, we want teachers to start by thinking, all right, what's the cognitive path? What are the things we want them to think about and learn about? And then once we get into it, that driving question has some version of create. And then we're using that to sort of pull out the pieces that we need to learn about, and helping students to understand that, and learn how to do that and develop that skill, so that when they become adults, buying a house, buying a car, choosing a university, whatever it might be, to use that thinking process and that mindset so that they can be more effective problem solvers. But in the academic setting, that is applicable as well. And I talk lots about, sort of the idea of push teaching versus pull teaching, and push teaching being kind of like what you said here, I think you said the algorithms are here, the things that you need to know, as opposed to pull teaching and giving them the opportunity to, and facilitating that process of discovering it. And then once we've identified that as what we need to know, now let's learn about it. And it might be direct instruction, it might be some experience, some
research on your own.
Yeah, could be a number of things. But the missed opportunity when we when we front load, is that we don't give the students the opportunity to develop that list, sometimes with lots of our help and manipulatively, because for us that's a really important piece as we think about preparing students for the modern world and problem solving, of being able to frame problems and doing that well so that we can actually solve them, as opposed to, because one of the things that direct and explicit advocates will say is that they need all this knowledge, and yes, they do need knowledge. I won't argue with that, but they also need to learn how to identify what knowledge they need to know. And if you don't develop that skill in them, when they get out into the adult world, there will be no teacher who will say, here's what you need to know about this. Matter of fact, they might tell you exactly what you don't need to know and mislead you. And so that, to me, that's a really essential skill that we need to develop.
I agree with you 100%. I'll take it one step further than that. Trust. So what do I mean by that? So you were talking about, I get frustrated when I hear oftentimes teachers, administrators who are not in the real world talk about the real world skills that we need. Okay. Trust is probably one of the most important things that you need in order to be able to work in that fashion you described a moment ago. A lack of trust will kill a project, will kill a company, will kill a team way before a lack of knowledge will. So what do I mean by that? Okay. What you just described there a second ago, Drew, that process where it's like, hey, we want to learn this thing. We want to do this thing. Let's talk about how we do it. Let's talk about what we need to learn to be able to do it. And going through that process, do you want to learn it this way? Do you want to learn it that way? How can we do that? Let's investigate it this way. Let's investigate it that way. Doing all those things as opposed to front loading, like you mentioned, what that does is that develops trust between you and the student. And to go back to a question you asked some moments ago about like, how do you start this? Like, do you have like different planning sheets and things like that? I don't talk about specific planning sheets in my book, but what I do talk about is spend a lot of time there at the beginning. Do not rush through the actual first prototype or the actual first thing that you want to create or do. Spend some time thinking about and talking about the problem and how you're going to go about solving the problem and what you need in order to be able to solve the problem. And from a teaching perspective, when you go through and do that, what you are actually then doing with your students is you are building trust with the students, because we talk about we talk about real world and we talk about applications of the real world. We talk about stuff like failing fast. We have to create a classroom where students are comfortable taking risks, and it's okay to fail. And we talk about that as if it's just a thing, right? Well, why is it not okay to fail for students? Why do students not want to raise their hand and answer a question, even if they're not sure if it's fair or not? It's because they lack trust. They lack trust that you are not going to protect them if they do give the wrong answer, and they're going to be laughed at by the rest of the students. They lack trust that they're not going to be laughed at by you, or that their ideas are going to be dismissed. And as a result of that, they themselves are going to be dismissed. They lack trust in all of those things. And what ends up happening is those ideas are lost and they're never shared and they're never exchanged. and I just, sit there and I just kind of do whatever. That happens in our classrooms every single day because we don't take the time to establish that trust and to build that trust with our students. And that also then is what happens in companies every single day. I want to hear your ideas. I want to hear how we can solve this problem together. I want to hear what you think our next great product will be. Well, I might share that with you and I might not share with you, but if there's no trust, then it's never going to actually be able to happen. To go through that process that I mentioned to you a moment ago, in which we're going to take an idea and we're going to build a product and we're going to send that product out in the market, that takes a tremendous amount of trust in order for that to be able to happen. So that process that you just described there, yes, it is teaching generalizable thinking skills, as you just mentioned, and I agree with you on that. Some things are domain specific, but some things are not, as you articulated well. But I think potentially, even more importantly, is you're actually going through that process with your students in the classroom as you are establishing trust with them, which is one of the most important things that you can then transfer into other domains and to transfer into other situations, which they're going to have to be able to do if they are going to be part of that product team or the head of the product team or whatever, to develop that great product and to be an entrepreneur and to solve problems and do all those things you just talked about a moment ago.
Well, you mentioned the book, and as we wrap up here, I wanted to make sure that we talk about it. I think we talked about it a bit and around it, but again, the title is What STEM Can Do for Your Classroom, Improving Student Problem Solving, Collaboration, and Engagement, Grades K through 6. So sorry, 7th and 8th graders. No, I'm just joking. I guess give us the elevator pitch if you want to add anything that you haven't already talked about, because I'm assuming lots of what we've talked about is certainly at least tangential, if not integral in the book. But yeah, go ahead.
Yeah. So my book is really, I love teaching. I'm no longer in the classroom, but I still love teaching. One of the perks of my job is I've been able to travel to every continent in the world and talk about STEM education, and talk about these things like project-based learning, to talk to teachers and students in classrooms all over the world. And the questions that I will get all the time are the same, no matter if you are in Kuala Lumpur, Malaysia, if you are in Jakarta, Indonesia, if you're in Bangkok, Thailand, if you're in Rio de Janeiro, or if you're in Pittsburgh, Pennsylvania. It is, I don't think I can teach STEM. I don't think I have the background knowledge to teach STEM. I don't know a thing about computer science. I can't teach it. You don't have to be a published author to teach language arts, but for some reason we think that you have to have a degree in engineering to teach engineering to your 5th grade classroom. So, being able to help teachers understand and realize that was the real passion behind the book, and being able to create the book, to be able to help teachers feel empowered to teach all these things that we just spent, the last hour or so talking about in this podcast, to be able to apply it and teach in their classroom. I don't want to give the teachers all the answers, because I would never think that I have all the answers, but instead I want to get them thinking. I want to challenge them. I do want to give them some things that they can apply tomorrow, like we talked about, but also want to give them more things that they can think about both today and tomorrow, and think about what is it they can do in their classroom. And that's really the purpose of the book.
Okay. Well, that is available. It's through Solution Tree, I'm assuming. Or maybe you can tell us where should they go to find that? And then I know you have a website, but what else should they know about where to find you?
Yeah, so they can go on Amazon and get the book. They can obviously go on Solution Tree Press, their website, to purchase the book also. But I think we're all on Amazon, so that's probably the easiest way to go ahead and get the book. My website is jmckenna.org. You can find all my information there about. I have a blog post that comes out every week. So if any of this resonated with you that we talked about here, I would encourage you to go and take a look at that. You can follow me on social media. My Twitter handle is @McKennaJ72. You can also follow me on LinkedIn. Search me on there. I'm active on both Twitter and LinkedIn. Again, sharing a lot of these conversations around teaching and learning, around STEM education. Also, as I mentioned to you, I do travel lots of my different travels, whether I'm going to FETC to speak at that conference, or I also participate in a lot of different research. So like AERA, going there, presenting at conferences like that. Some of my published work, you can go and check out on my website there and see all of that there. And you can also subscribe to my newsletter. You can go to my website and subscribe to my newsletter and get a little bit more personalized information about what I'm doing and where I'm going and all that good stuff.
Okay, well, appreciate that. We'll put the links to those things in the show notes, of course, and folks can visit that. It'll be on our webpage. Most of the folks listen on Apple Podcasts, but if you go there should be a link to click to view the links, and it'll take you to our webpage where you'll see those kinds of things. Jason, I appreciate the conversation, and hopefully, as I always say, hopefully folks found it helpful.
Thank you for having me.
What we need to do is spend enough time together that we can start to translate our ideas into each other's language and include one another in this community of inquiry. And that is the work of love.